for the introduction. Also, this is a change of the topic. Now, I have nothing to declare. Which one to go? Yeah. Okay. Now, oxidative stress is a fundamental pathological mediator that underlies many pathological changes associated with aging. In this context, the ROS-generating enzyme NOx has a particular importance because this is the only professional ROS generator in the body that produces superoxide as its sole function. Therefore, targeting this molecule can specifically inhibit excessive ROS production without compromising the normal biochemical oxidation. Therefore, there is intense interest in identifying or targeting the NOx subtypes in the body. Recently, we have identified NOx system in the bladder urothelium. We also demonstrated the functional importance of this system in the bladder. The results were communicated in the last ICS meeting. Now, the purpose of this study is to gain further molecular insight and also understand its pathological significance. In doing so, we have set up two experimental objectives. The first one is to examine the effect of NOx subtype deletion, specific subtype deletion, on NOx-derived superoxide production. We also examine the effect of several pathologically important inflammatory mediators. The basic experiment model is the C57 mice. This is the wild-type mice. On this background, the NOx1 subtype knockout and NOx2 subtype knockout were generated, and then littermates, wild-type littermates were used as a control. The tissue preparations are mainly fresh isolated bladder mucosa and full-thickness bladder tissue by microdissection. We used luciginine-enhanced chemiluminescence to determine the quantity of superoxide production in live tissue. We also used luciferin luciferase assay to determine the tissue ATP release. Now, this is the result of NOx subtype deletion. The plots are the level or relative level of superoxide production in different groups. You can see on the left graph, this is NOx1 specific knockout. There is a significant reduction in the superoxide production. On the right, you can see NOx2 knockout also produced similar effect. Then we look at the effect of several inflammatory mediators on the superoxide production. The first one is the angiotensin 2. Now, this is a trophic factor and also a vasoconstrictor that's endogenously released and also associated with bladder obstruction and bladder hypertrophy. You can see here, application of angiotensin 2 enhanced the superoxide production. The middle one is the GSK 1016790A. This is an activator of TRPV4 receptor. Now, this receptor is involved in bladder sensation and bladder pain. Application of this activator can also enhance the superoxide production. The third one, or the final one, is endothelin 1. This is also endogenously released in response to tissue hypoxia. You can see application of this mediator can also enhance the superoxide production. To add the functional relevance, we also examine the effect of these inflammatory mediators on the ATP release from the urothelium. Now, ATP release from the urothelium is the main function output of bladder urothelium. As you can see here, in two of the mediators tested, both increased the ATP release. The first one is angiotensin 1, that increased ATP release by about 50%, 100% in fact. Then also the GSK, the TRPV4 activator, can also increase the ATP release by a large proportion. So from this data, we conclude NOX1 and NOX2 subtypes contribute to endogenous superoxide production in bladder urothelium. Inflammatory factors, angiotensin 2, BBB4 activator, and endothelium-1 can upregulate NOx-derived superoxide production in the bladder urothelium. These inflammatory factors can also enhance ATP release from the urothelium. Finally, the effectiveness of these bladder pathology relevant inflammatory mediators suggests the pathological significance of NOx-driven oxidative stress. Finally, we would like to thank the funding body, UK funding body, BBSRC, and the US funding body, NIA, for the financial support. Thanks for your attention.
Please.
Yeah, Toby Chai from Boston. Thank you for that work. I just want to make sure this is a constitutive knockout for the NOx subtypes. So they're knocked out in the whole animal.
It's whole body knockout.
Whole body knockout.
Yeah.
So how do you know the effect that you're seeing is purely urothelial in nature when you knock it out?
Or we measured urothelium changes specifically.
Separated from the lamina propria? Because I think you're using mucosal.
Yes, yes, that includes submucosa. It's difficult to isolate the epithelial layer on its purely, but the main contributor is the epithelium. We have stained intracellular superoxide production. The epithelial layer would give the brightest signal.
No, I just wanted to say that, I mean, Carl Eric was a moderator in our AUA presentation, but
yeah.
There is a way to isolate this is a mouse, C57 black 6,
yeah.
so we use the same animal, but you can isolate the urothelium away from the lamina propria
yeah.
Separately as a tissue. It's probably will take practice to do, but there's a video of it on YouTube. You can get it, it's free. And it's published in Nature Protocols just last
that's
month.
Interesting.
So what's good is you can actually look at lamina propria if you're not interested in urothelium,
yes, yeah.
or you can look at urothelium if you're interested in urothelium, but that might be something to consider.
That's very good. How did they do that? Is that peeling off the epithelial layer?
Watch the video. You just have to make a special micro forceps. It was all done by...
In fact, we also did that. Not for the ROS production. Okay. We did that on the urothelial ATP release. In one of the papers, the AJP papers, we separated the epithelial layer very nicely. We differentiate the epithelial layer from the lamina propria. Okay. We did that, but not on the ROS production. It was very tedious, very, what's called
we timed the procedure. It's all in the video, how long it takes.
Yeah, I'll watch that video.
And of course, we presented data that was definitely, as best as we can, urothelial tissue versus lamina propria, so that, doing some molecular...
That's amazing. I'll look at this video. We'll introduce this method to our laboratory.